all the previous chapters, we were able to configure a fully working email service to which you can connect either via a GUI-based email software or with webmail. But our email service is wide open. Usernames and passwords can be seen over the wire. Contents of emails can be snooped and modified. That is not the type of service anyone would want to use. After all, would you have used Gmail if not for its security? In this chapter, we will tighten all the loose ends and make our email service very secure. We will start with SSL. What is SSL? Let's say that a client C wants to access a service from server S via internet. This service may be web pages, emails, voice, or video. Just about anything possible on the internet. SSL or Secure Socket Layer is a method of establishing a safe connection between a client software C and a service on the server S such that when establishing a connection, the client C is assured that the service on the other end is indeed S and not someone impersonating S. This is done using certificates. After the initial identification and verification, all further communication is in encrypted form, such that no one along the way can understand what is being exchanged and as a result cannot modify it either. You can read all about SSL in the form of a short story from the post on my technical blog Tech 101. To configure SSL certificates, we will use a tool called CertBot. This tool uses the popular service named Let's Encrypt to generate SSL certificates, which come with an expiry date. CertBot has some features that are useful. First, it sets up scheduled jobs to automatically renew certificates that are close to expiry. Second, CertBot is able to automatically configure certain services like Apache Web Server to use the newly generated SSL certificates. Our first step is to install CertBot. We will add the repository from which you can download and install CertBot. Thereafter, we will install it. Here is the sequence of commands. Let's generate our SSL certificate now. CertBot command will guide us through a set of questions. Here is the command to use. Remember to sudo. Let's break this command down. The -d switch specifies the domain for which we need the SSL certificate. In our case, that is mail.tech101.in. The cert-only command just generates the certificate and does not attempt to change any configuration files, such as Apache's, to use the generated certificate. We'll do that manually in Postfix and Dovecot later. The web root switch needs some explanation. When we install an SSL certificate to a server, the certificate provider verifies that a server indeed belongs to us. So they provide us with some verification files that must be placed inside our web server's path. The provider will ensure that those files exist on our server before they issue a certificate. CertBot has two ways of dealing with verification files. In one option, it starts its own web service temporarily and places the verification files within that temporary service so that the provider can verify our server. This is useful if you are getting an SSL certificate before having set up a web service at all. However, since we have our own web service ready from the last chapter, we will tell certbot to place the verification files inside our service. Note that we will need to tell certbot where to place the files. Where do you think they should be? Recall from the previous chapter that we created a folder with the path home DevOps webmail and installed Rainloop inside it. This path is to be provided as the web root when certbot asks us. So let's proceed. Let's enter an email here. It can even be your Gmail, but let's use Henry's email. Let's agree with the terms and conditions. Let's say no to the next question about sharing our email address with the EFF. And finally, to the most important question, the web root path. Enter home DevOps webmail here. And after a few seconds, the certificate will be yours. Note where the certificate has been saved. etc let's encrypt live mail.tech101.in. There are two files inside this folder, privekey.pem and fullchain.pem. Privekey.pem will be used to encrypt all communication between this server and email clients. The clients will be given a public key to be able to decrypt the communication. Fullchain.pem contains the certificate that proves the authenticity of our server. It also contains the public key that will be given to the email clients and to the browsers. Now we can secure our Apache, Postfix, and Dovebot. Let's start with Apache so that our webmail is encrypted. Note that Apache, Postfix, and Dovebot are all on the same machine, so the connection between Apache and Postfix and the one between Apache and Dovebot are within a machine and cannot be snooped outside. So webmail will be secure after you simply enable SSL on Apache. So let's secure our Apache now. Here's what we need to do. From the file etc apache2 sites available 000-default.conf, we need to copy the alias line and the directory section into another file named etc apache2 sites available default-ssl.conf. Next, we need to enable the website configured by default-ssl. You will see the default-ssl listed in etc apache2 sites enabled. Next, you need to enable SSL module of Apache. Now let's restart Apache. If you issue the command netstat, you will see that Apache is also listening on port 443 in addition to port 80. Port 443 is the default port for HTTPS or HTTP secure. In other words, HTTP over a secure SSL encrypted connection. Now when you request the page using HTTPS, you will see an error that the connection is not private. This is because our browser was unable to verify the certificate from the server. Here's our invalid certificate. It belongs to localhost and not to mail.tech101.in. We need to configure Apache to use the certificates we generated with certbot. Let's edit the file default-ssl.conf. Once again, we need to change the paths for the SSL certificate and key. Right now, they have weird values named snake oil, whatever that means. After the changes, we restart Apache. If you refresh the page now, you will see the webmail login page. The URL bar will show a lock indicating that the connection is secure and that the certificate on the other end is verified. Let's look at the certificate. You can see that the certificate is issued for the domain mail.tech101.in now. We also see the issue and expiry dates. Congrats, your webmail is now secure. But we will also need to step up the security on Postfix and Dovebot. Why? Other email servers, such as those of Gmail, will deliver emails to us by connecting to our Postfix. If we do not secure Postfix, all our incoming mails can be read and modified. If someone wishes to use Outlook or Thunderbird rather than webmail, then we need to ensure that those connections are secure too. For Postfix, let's start with the file etc postfix master.cf. Uncomment the line that starts with SMTPS. Just like Apache, we now need to configure Postfix to use the SSL certificates generated by certbot. Open the etc postfix main.cf file. Add the following lines to it. Below the line that says SMTPD use TLS, add the following line. Instead of the funny snake oil names, let's insert our certbot certificates. SSL will be enabled when we restart Postfix. I will teach you how to use OpenSSL command to test if a server is returning the correct certificate. In our case, we want to connect to Postfix, which is running on port 25. The s_client subcommand says that we are using OpenSSL to behave as a client to an SSL-enabled server. OpenSSL command can also be used for other SSL-based purposes, such as to generate keys. The connect switch in OpenSSL connects to the server localhost, which is the server itself on port 25, where Postfix is listening. We have configured Postfix to accept non-secure connections and then upgrade it to an encrypted connection only if the client is ready for it. So we use the start TLS switch followed by SMTP as the name of the protocol, mentioning that all further encrypted communication will use SMTP. If we do not use the start TLS switch, OpenSSL will try to connect to the service using SSL mode right from the start. The server won't provide any certificate and the connection will fail. And right away, you can see the certificate returned by the service. It is the certificate that belongs to the domain mail.tech101.in. Accurately, this is the certificate that we generated using certbot. So Postfix is ready. Now let's turn to Dovebot. We need to change etc dovebot conf.d 10-ssl.conf file. Let's take a backup first. Let's open the file. I think you can guess where to change things by now. SSL_cert and SSL_key. Let's do it. With that, we can save the file and restart Dovebot. Let's try the OpenSSL connection command on Dovebot, which is running on port 143. The protocol should be IMAP instead of SMTP. We have the correct certificate indeed. Now it's time to test those settings on our GUI tools. Let's start with Rainloop. We aren't going to make any configuration changes to Rainloop since it is accessing postfix and Dovecot from within the same machine. But we will still send and receive sample emails to check how our new SSL connection works. Here is an outgoing mail. Let's try an incoming mail from Gmail. The mail has reached our inbox. Let's check how secure connections work with Thunderbird. In the hamburger menu on the right, choose Preferences, Account Settings. Navigate to Server Settings under henry@mail.tech101.in mail account. Change the connection security setting to Start TLS. In the outgoing server settings, click on Edit and do the same thing with connection security. Let's try to send an email. The mail was received by Gmail. You can see that Gmail does not show the small red lock icon with a strikeout that signifies an insecure email. That's because we used SSL while sending the email, and Gmail is confident that no one snooped the mail along the way. With SSL done, let's take up the next security measure, DKIM, which stands for Domain Keys Identified Mail. Sounds quite a mouthful, but let me explain. What if you could know for sure that an email was sent exactly from the server which the mail claims to be from? And what if you could rest assured that your mail was not tampered with? That is the purpose of the DKIM security measure. There are two concepts that ensures that DKIM is indeed a safety measure. The email server that sends an email possesses a private key that it does not share with anyone else. This ensures that only this server can use this private key. The public key that corresponds to this private key is stored on the DNS server so that anyone can fetch it. Using the private key, the email server calculates a hash of the entire email message or that of some important headers that mustn't be tampered with. The private key and public key are so designed that using either key generates the same hash from the email message. When the receiver receives the email, it stores the hash from the header temporarily. Then it obtains the public key from the DNS service and calculates the hash using that public key. The hash calculated by the email server using its private key and sent to the receiver, and the hash calculated by the receiver using the public key must match. In case of a mismatch, one of the following things is assumed. The calculated hashes do not match because the private key used must not be the one corresponding to this public key, so the server is an imposter. Or, the calculated hashes do not match because the contents of the email were tampered with. Either way, the received mail will be rejected or at least marked unsafe. Let's learn how to set up DKIM protection for our email server. We'll start by installing two packages, OpenDKIM and OpenDKIM Tools. Let's change to the directory etc DKIM keys, create a directory for our domain, and generate a DKIM key. Let's understand the command. The -b switch tells OpenDKIM to generate a key that is 2048 bits or 256 bytes long. The -d switch is to mention the domain for which to generate the keys. The -s switch is called the selector and will be the name of the private and public key files generated. -v switch means verbose, that is, the command will output its progress as it proceeds. You can see from the verbose output that a private key and public key were generated. The private key is in the file email.private. The public key is embedded in the file email.txt, which represents the DNS record that must be inserted into our DNS server so that all email servers that wish to validate our emails can get hold of the public key. Note that the name of the TXT record that must be generated has the name email._domain key. The part before the dot, that is email, matches the name of the private public key pair that we used in the -s or selector switch in the OpenDKIM command. The part after the dot is always _domain key. We should make the user OpenDKIM and the group OpenDKIM the owners of the private key. Let's create a record exactly as instructed in email.txt. Please note that while entering the name of the record, we need to enter it as email._domain key.mail instead of just email._domain key. This is because our DKIM record is for mail.tech101.in instead of just tech101.in. Had we been configuring our email addresses as @tech101.in, then we'd simply use email._domain key as the record name. Now we can verify if the DKIM record is active on the DNS server. We can see the command verifying the presence of the record on the DNS server. It also says key not secure. This is because we are using plain DNS and not DNSSEC, which is a secure version of DNS protocol that still needs to be adopted by the majority of the internet. We now need to make sure that Postfix attaches a DKIM header to every mail it sends out. We can do this using the OpenDKIM server. We have already installed it. Now let's edit the file etc opendkim.conf, first taking a backup. The UMask should be 002 instead of 007. We need to sign all emails going out from the addresses ending with @mail.tech101.in with the private key we created a while ago. Let's configure that. Since Postfix wants to talk to OpenDKIM and Postfix can only access file within the where spool postfix directory, we will create a new socket file for use by both. The folder should belong to the user OpenDKIM and group Postfix. Edit the opendkim.conf file again and change the socket file name. Let's connect Postfix to OpenDKIM. We need to edit etc postfix main.cf. We'll first make a copy of the file so that all the changes up to SSL TLS are safe. Now we'll edit the file. Add the following lines after the SMTPD restrictions. We added 4 lines that have one word in common, milter, which stands for mail filter. Milters are useful for 2 things. First, they can filter out unwanted incoming mails such as spam or unauthorized ones. Second, they can add authentication headers to the outgoing mails so that other email servers are assured about the identity of our server. The third line, SMTPD milters, is used to specify a set of milters through which our mails should pass. We have mentioned the DKIM socket file that will chain all our incoming mails through OpenDKIM software that we configured a while ago. Mails coming through non-SMTPD protocols such as LMTP are told to use the same filters. Milter default action is set to accept just in case a milter does not execute correctly. Instead of losing an email due to malfunctioning milter, we will tell Postfix to accept that email as valid. Postfix uses a standard communication protocol to talk to all milters, to send emails to them, and to receive the status. As of today, 6 versions of the protocol have evolved. So we will use version 6, the latest one. Now it's time to save the file and restart both Postfix and open DKIM. It's time to send a test email from our server to Gmail. Let's first keep our mail logs open so that we can see the DKIM process take place. Now we use our webmail to send an email to Gmail. Gmail has received our mail. In the menu on the right, let's choose the option Show Original. You can see that SPF and DKIM have passed. Congratulations! You've got yourself a secure email server running over SSL where you're assuring that your server is the genuine sender. This concludes our basic course on how to set up a self-hosted email on Ubuntu Linux. Let's summarize everything in the epilogue chapter.